Alright, hey guys, my name is Luis Hernandez and my topic is on area underneath the curve. This topic may seem as an easy topic or a hard topic depending on you, and it's totally up to you, but I'm going to explain it today. So, first off, what is it? Area under the curve is basic definition is the area in between the graph f of x and the x or y axis. So basically anything in between your f of x function and the x or the y axis. The two words that stick out from area underneath the curve are area and curve. Area is a pretty intuitive word. For example, in a square, everything in blue is what you're looking for, which is like a general section within that square. That'll be defined as your area. In a more mathematical way, you could define it as side times side. So that's like a mathematical way of finding the shaded region within. What sets this apart though is the curve. As you can see, rather than a square or like a circle or whatever, you have a function right here along the graph. And when you're looking for area underneath that curve, you're looking for everything in between this general section with given points. I'll get more into detail down the line. But continuing on, why is it important? Area under the curve is important because it can either tell you the distance, the velocity or the speed, the position, or even the acceleration of a particle. You look at the area underneath the curve to determine like if the f of x function shows its position, it'll give you its displacement, the area underneath the curve. If the graph shows the velocity, the area underneath the curve will show you its position, and so on and so forth. Continue on to that. How do you find it? The most important one, or like the most common one, is Riemann sum. That's like the most basic way of finding area underneath the curve. However, unfortunately, that'll give you like a rough estimate. It can give you like a clear like number, but it's not as clear or definite as say integrals are. Integrals are like the most important way of finding area underneath the curve, or like the most definite if you want to get really exact. So how do you take the integral, you may ask? So the generic function is to find the area is from the integral from a to b of f of x dx. As you can see here, this is a more clear like representation. Here's your a to the far left, and here's your b to the far right, and your equation is denoted as f of x, and everything in between is the area that you're looking for. As I mentioned, a is always going to be the one least, like the number to the least or the lowest point, and b is going to be the highest point. It generally takes into account like the function, everything in between the function and the x-axis, or you could also do it along in respect to the y-axis, but it's usually like denoted between the f of x and the x-axis. This has a real-world connection to many things, whether we know it or not. You can connect it to engineering. They use like graphs and different like measurements to take into account, say, a car's velocity or distance or acceleration. Here we have an example of a graph from a dynamometer, which measures the car's speed, and everything in between is what will show you the car's like potential power or power that it creates from the graph. It's also used in construction or architect to build staircases, or as you can see here, a roller coaster, and it's mostly implemented in mathematics to like create intellectual thinking and further like development or other mathematical strategies. The question asks to find the area between the function f of x 7 minus x squared and the x-axis in between the points x equal to -1 and x equal to 2. I already drew out like a little rough sketch of how the graph would look with the points. So everything in blue is the generic like section of which you're finding the area of. So the blue is basically the area that you're taking into account. So you have your points a and b. -1 is your a, 2 is your b, because you always want a positive area. And you plug in your f of x, which is 7 minus x squared, and then you plug in the dx. So basically all you do is just integrate the f of x function, which leaves you to 7x minus 1/3 x cubed. Once you have that, you're just basically going to plug in your points, -1 and 2, and you're going to subtract the biggest one from the smallest one. So 7 times 2 minus 1/3, 2 cubed, all minus 7 times -1 minus 1/3 negative 1 cubed. And you basically just do basic math and like solve that out, and your area for this case would be equal to 18 units. Simple as that.